If you're dealing with algorithms, you probably have heard the phrase big O notation, and the definition given on Wikipedia is quite scary. So what is big O notation? There are plenty of algorithms in existence that take specific inputs and produce specific outputs, but not all algorithms are just as efficient. Simply put, in computer science, big O notation is a way to classify algorithms by how efficient they are, based on how long it takes them to perform the computation and the size of the input data. You can also view this from a different perspective. Big O can tell you how much the algorithm slows down as the input size gets bigger. In this graph, you can see elements on the x-axis and operations on the y-axis. Elements are the amount of inputs we have, and the operations are the amount of actions we take to process and compute from an input. In terms of code, you can think of an array with 4 items and a loop that goes through each one of those elements in the array. The items in the array would be considered elements, and the loop count would be the number of operations. Big O also has a complexity chart, and it's not as complex as it sounds. This is how it looks like. Each drawn line or curve represents one of the big O complexities, and these complexities in their turn represent how efficient an algorithm is, using that notation. Slower algorithms increase their number of operations far quicker for the number of inputs it receives. But what is the difference between each one of those complexities, such as O of n and O of n's factorial, and how are they calculated? There are a lot of complexity types, but these are the most notable ones for computer science. The list is sorted by the most efficient to the least efficient big O complexity. Constant complexity means that every single input requires a single operation, for example, a variable assignment. The linear complexity, however, means that the amount of operations required to calculate grows proportionally to the size of the input that it is given. If we had an array of 4 items and we looped through it 4 times, the O of n would be O over 4. To calculate the big O for an algorithm, you could either identify all complexities and add them up together, or a better way is to follow these 4 rules. Finding the worst case simply means how many steps it would take at most for an algorithm to calculate. For example, in a 4 items array, the worst case of finding an item would be 4 steps. Removing constants is useful as the n number gets much bigger compared to the constants present in the algorithm. There is also a common misconception that if you have 2 functions with linear complexity that process 2 sets of input, that the final big O complexity is still O of n. This is false because these 2 input sets might be different. One might have 100 elements and the other 100,000 elements. So it's important to bear in mind that in this case, the big O complexity would be O of A plus B. Nested loops, as a general rule of thumb, have each its own complexity O of n, and is multiplied one by the other. So having 2 nested loops would mean that the big O complexity is quadratic. Finally, if you have multiple terms, some of them might be considered dominant and some of them might not. The most important term is the dominant term, and you can quickly find out which one it is by inflating the input count to a large scale and seeing which one of the terms would give you the highest numerical output. In this case, it would be n squared, and therefore you can omit the non-dominant terms as they are going to be numerically insignificant. Hey guys, if you've enjoyed this new video format, make sure to hit the like and the subscribe button. Thank you very much for watching, and I'll see you in the next one.